stay fix my stuff.
So like I said, I'm going to say this so it's on camera. This is a ladder and then 4 or 5 numbers. After that, I explain all that to you guys. You can figure that out. Show me, right? Anybody lost yet? Don, you good?
Camera working.
Yeah.
What is G code?
What is G code?
Why is it going to be the letter G? Why can't it be the letter J?
So then the first tool, we're going to face this off because this is 1x2 material and it says 0.8750. So tool 1, your face mill. T1 is tool 1. And M6 is your tool change. So that's going to tell us to go to tool 1. This year we're keeping all the probes in the very last one. So the probe will either be 10, 20, or in the new machines it's 31.
Does it have to be T1 and 06? Because you do M06 T1.
And that doesn't matter. The spacing also doesn't matter. It reads the whole line at a time.
Right, I just want to make sure it was the same like as you would put it into the MDI screen that you can flip flop.
Yeah, you can flip flop.
Okay.
You can flip flop any of these as long as on the side. You can put G90 over here, G0 over there. It doesn't matter. All these are is cancel codes. So G's, or except for the G0, that's a rapid move. G20, G40, G49, G80, and G90 are, this is not a cancel code, this puts it in Chinese or something. Like I said, all these are in your book. Then you go S, that's your spindle speed. We'll go over how to calculate those. And then M3. G54 is your offset, and then you're just going to a pre-start location, which is X of 5.5 and Y of 0. So where would, if my 0 is here, X of 5.5 and Y of 0, where would that be?
It goes center line 5.5 inches off the x-axis.
To the right or left?
Is it negative?
Positive.
Positive. The right.
To the right. So it's over here, right? So then G43, that is your height offset for your cutter. That's why this H1 has to match the tool line. So if this is tool 2, this is H2. And then a Z of 1.0. So now we're an inch above the part. G01, which is a cut move. Z of 0.1, because we don't do rapid straight down this device in an unproven program. Feed rate of 25 inches a minute, and M08, which turns coolant on. So now we're going to go down to Z0. Dude, I seriously, I did take on that one pass. And then an X of negative 5.5 and feed rate of 60 is what I put. So it's going to start here, it's going to go all the way off. The thing that you use to figure out this 5.5 is distance from here to here plus at least half of your cutter, so that you don't start your shell mill on top like this. You want your shell mill over here when you start. Follow, John? No?
You don't want your tool to start on top of your part in case you screw up when you're offsets, the tool can slam into your part.
Does that make sense? So you bring it down inside your part right here, just like your programs usually do, right? And you face mill across and off and back up. Otherwise, you'll leave 2 different sets of swirl marks in your part too. Because you can literally mill to here and then pick up, but this is going to have a different finish than it does back here.
I got a question.
Uh-huh.
Why is it say 0 when it's across?
Because I guess the top Z0. So I probably finished, I set 1. I haven't looked at this program lately.
Well, I guess it drops down.
It drops down right here. This makes more sense. So the first one's Z0, it'll just skim it across. That way you can see if it's wrong or not. And then just the top of your stock is Z0. So if you take off 100 thousandths on your first pass, you set your offsets wrong somewhere. And then, so the next one is a feed rate. And this doesn't even have to be in here. You don't have to put the feed rate every line. You can just go back and forth. So X of negative 5.5, feed rate of 60 out. That's the first one. And then a Z of negative 100 thousandths. So it's going to drop 100 thousandths. Then it's coming back to this side of 5.5. So we're just going back and forth. So it drops 100. And then it drops down to 125. and then it goes back the other way. Finish it off. So the first pass takes almost nothing, the second pass takes 100, and the last pass takes
More of a finish.
25 more. So you'll get a better surface finish.
Now, even if you wanted to too, you could just add an additional line in there to maybe change the feed rate or the speed of the spindle to get a better finish.
On your last pass.
Yeah.
All you would have to do would be, if you take this F,
feed rate in, yeah.
and you put it right here, it's a changer.
Yep.
Or right here.
You do that, so you have to put it in either the line before or the line of the moving
Yeah.
3x. Okay.
The line of would be the best.
Yeah.
Because there's no point in slowing it going down. That doesn't matter, it's in there.
It reads one whole line at a time, so it doesn't matter where in the line it actually is.
Yeah.
It'll just see the entire.
Well, it also wouldn't matter, you could put it here, it's just gonna slow down your drop.
Yeah.
Over here, it's just gonna slow down and lose cross. G0, rapid move, Z.1, we're just going back up above the part, or one. A Z of 1, and then M9, M9 is just cooling off. M5, spindle off.
Who?
The one in the, sorry.
Jake.
Okay. For some reason, his modules in this class opened just fine, but when he goes to college, they won't open. I gave him a different laptop, and he tried a different laptop, and it still didn't work.
Okay.
Now, another student didn't have that problem. It opened for the other student.
Okay.
So,
Could be operator error. Okay.
I don't know, I watched him do it.
I'm gonna grab him and pull up the laptop and see.
That's fine. Thank you. These little notes off to the side to help you, so when you forget G43, full height offset. This side here, a little bit of feed rate of 25, turbo coolant. You can't see the rest. Move to Z0, feed rate, so you can follow these little notes, John. Try to help you as much as I can. I'll type the next one when we go over it in class probably. I don't like doing it this way. I'm gonna try to do it like I do the videos. So then we do let's see, before he came in here, we were G0 rapid move, up to an inch, cool it off, M5, spindle off, G91, G28, Z0, that takes the Z to the home position. And you don't necessarily have to put an X and Y in here, because if you put an X in here, it slides all the way up to the corner. You guys remember how I did that? He's gonna do. So if you just do G28, G49, Y0, it slides the table straight to you from wherever it's at. It won't slide it over.
Depending on what your device is, though, because you can put an X value in there for whatever you want.
Yeah, you can. That's what it says here. Return to X0, Y0. So if you want to return to something else, you just change it to the something else. G90 turns absolute programming back on. And then M1 program stop.
So does G91 turn off absolute programming?
That should be right up there somewhere. I think I put them all in there. Maybe not. It's all in your book on one page or 2 pages.
Yeah, that way it goes back to the machine's home instead of the offset's home.
Yeah. So then,
Now, is M1 a hard stop, or is that your program? Is it like the actual program startup?
what's a program stop? So if you have
Options about.
an optional stop and block delete on the stop.
Okay, and then M00 is a hard stop. You'd actually have to press cycle start regardless if you had option stop on or off.
Yeah, I didn't use M0 in this class.
Oh.
Because of what we do. This is the best way. And it's also best. You guys I want you to follow my layout when you write your program, just because then when you have problems, it's easy for me to fix.
The only
Plus,
reason,
it's written right here for you and it's explained.
yeah.
You know what I mean?
No, the only reason I know about M0 is because
You guys did the work, yeah.
it's just easier for flipping parts around because you can just have a single program and you don't have to worry about if you forget to turn option stop on, it's not going to run through the second part.
No, I
Yeah.
in this class you can use it. I don't care.
I like to make another.
What we usually do for size of the program is we just write different ones.
Yeah. I might make another one too.
Oh, T2, we're gonna build down the edges. So I picked a 3/4 inch end mill, big end mill, nice sturdy. Won't have about a bunch of cutter flats, okay? Tool pressure won't mess with it. What?
I broke a 3/4 end mill before.
I broke one this summer, it took it off like 100,000. So I'm like,
Mine
one of you all had to stress fracture that thing first.
So this is why you don't start the cutter on top of your tool, is because I tilted the mill head years ago. I was like, oh, it looks clear, even though it's still over the part, and it goes whack, 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 whack. Almost pulls my part right out of the vise and shoves a whole flute of the infill like, down the shop.
Because your teeth wasn't on it, so it looked like it was clear.
Yeah, because I had the
You
teeth
could also put it
sideways
in
and it
neutral,
just,
or you could spin it by hand.
I should have.
That doesn't happen.
I should have done both, you know?
So, left side of the part, and this is how your guys are written. So, I'm going to do the left side of the part would be over here, right? T2, M6, we explained that up there. This is the same line as before. M3 does what? Spindle speed. G54 is your offset. X of negative 3.75 and a Y of negative 1.75. So where is that, John? If this is 0, 0, and you go like this, these ways are positive. You know where this negative is? Negative 3.475 would be how far from this hole?
Like, near the left side.
Yeah, it's over here, right?
Yeah.
The way I figured that out is I went from my center line on my print to here, and then you add half the cutter to compensate for half of the radius of the cutter. So your spindle's running actually over here, which puts your mill right on the edge.
And you gotta make sure you put the right correction or directions, you don't wanna.
Well, this one you program the direction by the numbers.
Right now, I'm saying, like, you wanna make sure you're not, what is it? You wanna make sure you're climb milling, not conventional milling, right?
Correct.
Okay.
High milling is this way. Conventional milling is this way. Conventional milling you feed into the travel.
So it pulls, the cutter pulls
Feed
the
with the
material
travel.
into it versus you pushing the tool against the.
Yeah. Otherwise, your backplash will try to suck it into it.
Yeah.
These machines aren't so bad, but I've created some machines that you can like take them like this, and if you do that with one of them, your cutter explodes. Or you put it in part otherwise.
Yeah.
G54, so our offset. So we're down here. So I took, and this is 2 inches wide. So an inch is halfway, put you here, and then I just did the whole diameter and cut it this way, just so I start off the part. G43, your tool offset, H2. H2 matches tool 2, and Z of 1 inch, which is where my height is. We're 1 inch above the original stock. Then we're going to do a G01, a Z of 0.1, so now we're 100 thousandths above. That's just so when you're running in single block, it'll stop right there and you can look at it before you plunge into something. Z of negative 1.2, and 8, I went 200 thousandths below the material, so it doesn't go hang your flip on it. And then the next move is a Y of 1.750. And if you notice, since my 0 is in the middle, this number and this number right here are just opposites. And then when I got done, I did a Z of 0.250, so we're a quarter inch above. And then I just slide over to the other side. Same way, G0 to the opposite of this, G01, Z.1, so I copied this line, copied this line, copied this line, and then that's the opposite, and you go back up. So I followed it, I go too fast. Now I really I can see it here in the headlights. Your book will help you with the coordinates stuff, we can go over that later. I'm trying to refresh 118's memory so that they can write their program.
Oh, I already got mine ready.
Yeah.
Oh, same.
You're not old. You got yours done too?
Yeah, it's like, I was writing through there and it goes fine everything.
Does it?
Yeah, I think we're all done with ours.
I'm trying to write a program, I'm trying to draw print for another place stuff.
Oh, you want to do feeds and speeds, didn't you? Let me run through this real quick and then we'll do feeds and feeds and you guys can, well, we gotta go through the pro too.
I'm not in a rush at all, so.
Few dots, like, I'm cool. I saw your due date already.
I actually didn't.
You didn't?
No.
Put it in there just for you. think I put one in there already. So your spot drill, we're going to spot drill 3 holes. We made it the next tool, tool 3, and I used the 750 spot drill because I want to put a little chamfer on this hole, a little chamfer on this hole, and I think we might even done a little one on that hole. So M6, T3, same thing as before, G54, and then we go to the position of our first hole, which is negative and a Y of, which would be this one. Because if you look, this hole's not on center line, it says that's 938, and this is 2 inches. So we're right here. Then M3S 4800, all of these are wrong. You guys are gonna have to fix them, or a lot of them are wrong. G43 H3 Z of 1 inch above the part, so that's your offset. A Z of 0.1, so now you're 100 thousandths above what it used to be with stock.
So is G43 a rapid move, or is that just the offset?
G43 is the offset move, but it'll also move over to, it's gonna move to wherever you put it.
Right, and the default is just gonna take whatever the machine's feed rate is, and then you put in a code specified. Okay.
Now, if you use the same feed rate, you don't have to change it.
Yeah.
So Z of 0.1, so you're at 100 thousandths above where your stock was, but keep in mind, we're already down to this 875. So you're
You have more clearance.
125 plus the 100, yeah, you're gonna be like a quarter inch away. Then we do a can cycle, which is G82. These are all new books. And they went down 532 thousandths. So when you do these holes, you take your spot drill 45 degrees, right? And then you take the diameter of the hole that you want. So the diameter of the hole is finished at 530. You divide by 2, and then you have to add all the material that we took off the top. And that's approximately how much you can down. Now when I program the spot drills, I usually mess up my offset by 20 thousandths and make it take the tools like 10 to 20 thousandths so that it doesn't go in deep enough.
And you can
So that you
fix
can
it.
stop it after the first hole, you measure the width of your chamfer, yeah, and then you adjust your offset. So it works right.
You said you take the diameter of the hole divided by 2, and you add that to the
You
depth,
have to add that to whatever
how
you
much material you took off.
whatever you took off the top we've shown on it. Because it
Okay.
still thinks,
Right, because he's still,
it thinks Z0 is here.
so you would take like 20, basically you take 25 divided, and then you add it to the 875 to get how deep you
Now
want
you
to go.
add how much you took off.
Oh, that's right, yeah.
It's about 125.
So it'd be 150-ish.
So you should come up with this. And the feed rate, we'll go over how to do those in a minute. X, Z of negative 1.87. Yeah, is that what you said? Something like that.
About, I just did, yeah.
And then X of 1.9375, Z of negative 532.5.
So we're going down half an inch.
I lost myself here somewhere. I don't like doing this way. It's confusing. So here's your first one.
Was that the middle hole then?
Did I mess up? Oh, they're all 3 on the same center line, that makes sense. So here's your first hole. This is the second hole. X0 Z of 0.187, which is what this figures out to be with the chamfer that I left on it. So if you're not changing your height of your chamfer or your width of your chamfer, you don't have to put the Z. You can just do X and Y's. And then the second one I did X of opposite the one up here, positive 1.9375, and then the Z of negative, so it matches the same as this hole. So we did that.
The R in that first line, that's the radius you're putting on it, right?
The R
Yeah.
is the retract.
Retract.
That's what it's gonna retract to after the bezel. So it's gonna do this hole, and then it's gonna retract to 100 thousandths above the original stock. It's gonna go over and do that hole, retract again, over and do that hole.
Okay.
G80 is the cancel for this can cycle. The can cycles, most of the cancels are, like if it's G82, then the cancel will be G80. Just like if it's 41 or 42, the cancel is 40. If it's anything with a zero usually. M5, G91, G28, Z0, G28. You guys know what those are. So this takes your spindle home. This takes your table home, G90, M1. And then the drill, it's M6. I made a tool 4. There's your offset. There's your speed. G43, H4, so that 4 has to match. And it does. Z of an inch above the part. Z of 0.1. G83 is the cycle I use for the drill, which is should be a PEC cycle. Z of negative 1.2, because we want to make sure we go all the way through so you don't kill the reader like you did yesterday. Tried to.
And it still reads.
It does. I don't know how. I don't know why it didn't break. Feed rate of 48 and a Q of 0.2, so I think that should be a 200,000 PEC, which is huge for its
Those I'm not even used to PEC cycles anymore.
Then a G80, cancel that one. Z 2, and then the same thing again. So I gave you this program. Your guys' is so similar. I know what all they were doing by the end of the semester. I shouldn't, because you guys don't have to type it, but they were pulling mine up and just changing it. I don't know, some of you just wrote your own. Yeah. He's like, it's faster to just write it myself.
Yeah. And get better use of knowing what G code means what too.
That's the big thing. If you do it that way, you don't remember the codes. And the second module, you have a quiz on the simulator.
So this will be so much easier when I have 2 screens but have the blueprint right here.
So module 2, there's a test about how to do this on the simulator. You gotta program the simulator. And I gave them a cheat sheet. This is only not too bad I did. I gave them the G codes.
Am I gonna get one?
Yes, I'll give you a cheat sheet.
You say, or you just let us make our own, because if we forget something, it's on us.
No, because I only want you to have certain things.
Codes.
I just gave you G and M
Yeah,
codes.
that's what I was gonna put on, was G and
I just took the book and I just copied it on the pages. Then they use.
I don't know, that's just figuring out points, man. Make sure you just write G and M codes.
Make sure you do it the right way.
Really, you don't even need any M codes in there,
Put it through your spindle.
but, actually, you can't see that on the simulator.
That's true. I'll actually run through that one.
Sure will. As soon as you turn it on, it says spindle spinning.
I would say
10,000.
I can't also look through the code. I didn't much last semester. If they could just make it run on the screen, I was pretty happy.
If it meant the right shape, it would give you points.
Yep.
So we're just gonna work on writing this down today then, getting our code and stuff.
Yeah, this is, well, idea is you guys, we have stock now. So you guys run this one that I did today. And then over the weekend, you can program the other one.
Dude, we got 2 physics homeworks to do this weekend.
Yeah.
So,
Physics
the first
homework.
one's due. Isn't it?
I think so.
I didn't say it was due on. I didn't say that
Well, this is due on Sunday.
Sunday. When I say write it over the weekend,
I'd rather just start writing it now.
but you still have to run this.
Yeah.
Now, if you wanna, I would prefer you ran this one first, but if you wanna run them at the same time, you can go ahead and write
You
this.
have tools set up already.
They're not the same tool probably. Some of them.
You don't make them use the probe or you don't.
You two have to use the probe. I don't want you three. We're gonna go back and forth. I haven't quite decided how we're gonna do yours, because when Justin took his group to Worlds or Nationals, they didn't remember how to use Edgefinder.
You know what's crazy? We had to use it at state, and they said I couldn't use a 1, 2, 3 block. So I could touch the spindle and stuff off with it.
Did you need to touch off piece thing?
No, the spindle.
Yeah.
Got the 2 knobs. I used the parallel. wax.
I would have said it's three, but at that point, I got the piece of paper, I checked my tool up, and I went like this, and went whack.
Well, yeah, because you just subtract the tool side from it.
You had to touch tools off on the part. They didn't have a tool setter.
Yeah, that's what I mean, though. If you touch them off into a spindle.
Yeah, but you got to spin off them more, so it knows how long the tool is.
Okay, that's the way you're going. So you can do the math, put it in your offset.
Yeah,
I'm pretty sure these machines are smart enough that if you touch it off on a piece of paper, it'll work. Because it'll calculate itself out. I believe.
yeah, that was really spin.
I mean, we don't usually let students do that, I don't want you to have parties around or something.
Still make sure you're on your tool offset instead of on.
We had somebody that broke a 2-inch insert drill, 2-inch diameter insert drill fight. I don't know how they did it, but they did it.
2-inch diameter.
Insert drill,
How do you know where to do it?
probably 2 inches, 3 inches,
They got a chip in.
maybe. No, I mean, like, they didn't break the insert, they bent.
Yeah,
Drill.
They got a chip in.
Yeah.
If it wedges a chip up between the flute, they're pretty fragile at that point.
Yeah. Crashed the whole machine.
It sounds like somebody was pecking too hard.
We don't peck drill.
We're not pecking at all.
Yeah, we just,
You went straight
Send
to the
it.
line.
and
That's what we do with all of ours.
yeah, as fast as the peck drilling.
There's a lot of stuff we're running like castings and stuff too, so it's like crazy.
I mean, I would expect them to peck on Hastel way, we just 2/10 of an inch per rotation, just send it through.
You don't have
This
to
machine
pull it
goes.
in a galley pack.
I know,
There is a deep hole pack where it just kind of this, just barely bounces, just enough to bring it. Yeah.
but program will put it that way, so that's the way we do it.
That's the way you ran it?
Yeah. It makes a very wonderful high-pitched squeal.
Oh, God,
All
that
of
does.
them drills do.
Yeah. But
So-
when it stops making noise, that's good.
Center hole reamer. I don't think you guys have a tapping set, I believe. We'll go over the tap cycle before you run it. Kill a bunch of taps.
The print I pulled up in the module doesn't have
It's got a tap hole in the middle.
doesn't say tap.
118.
It says 1/4 inch, 1 inch down, 80%.
No, you gotta program that. Go to this tube. There's another one.
Sounds like what?
That's added. Put on that one, sure project.
Okay.
That's the one you got.
So when you send the machine home, what exactly is the machine ID do? I know it's incremental, but what purpose does that have?
No, it puts it back in. I don't wanna say it wrong, so I'll go back here. Here we have this.
That's your- That's your-
I'm not that good. There's a lot of videos in the just program.
I think it puts it back in.
It's an incremental position.
Incremental.
I was just asking, like, what difference does that make? Machine home.
That's the question. We're gonna answer to that one? I was just, this is the way Justin writes for this class, and they want us to teach them all the same, so I was just following what he did.
What's the question?
He wants to know why your G91. It puts it back in the incremental, but why? It probably puts it back in the incremental, so it knows where, so it goes to the right home. It offsets your, it takes it away from your offsets and puts it back on your machine.
It says it does it to prevent it from going to the immediate or intermediate position, which is where your work offsets are.
Yeah,
Yeah.
so it's taking it out of your work offsets and putting it back to the machine offsets.
Where do I get the program so I can run this?
You gotta make it.
No, the one you're giving us.
Oh, it's on my USB, or I'll put it on there.
It's on the shoe.
So then, hang on. I'm gonna go through the rest of these real quick. I'm gonna go faster though. So John can be my help later, and then we're gonna go out and we're gonna work on how to calibrate the probes and go through them.
So we're gonna actually start the machine today.
Huh?
Are we actually starting the machine today if there's time, or?
You can. There may not be time. I wanna make sure you guys know how to hit the probes.
We're gonna
It's very expensive.
Yeah.
We're not doing it.
So I need good work.
He dropped the probe.
We just have one camera.
Remember when we were having problems with the soul change and I hit the button, I was sitting there trying to get it out, and as soon as I let go of everything and turned to walk away, I took 2 steps and it hits the whack.
There was one of the kids last semester in our class when we only did the probe like once. The one you set your tool off with, he just took a shell and went right through it.
Show me, right?
Right. Because I guess he was getting it set up over it so he can get
I
it.
need some more material.
Look at that cabinet, I think there's 1 or 2 pieces left, otherwise there's 12-foot sticks on the ground.
He was getting it over the setter so that he could start the actual machine programming for the offset, and he put it in the wrong. I guess it was when he put it in the wrong jog mode and just cranked it right down through the post.
Or an NPI. That's 12,000.
Well, spindle wasn't running. He just broke off the arm of it though. He just
The arm, if that's the only thing you hit, the arms are kind of made to break away.
yeah.
At least it does that. You just don't want to hit the black part. We don't really want to hit the arm either, because I have to go find a video to fix it. We do have videos on how to set it up and calibrate it, but I like those very much. So reamer, basically all this stuff's the same. You do a G85 is the G code I use for the reamer. Go down -1.2. This view rate is so wrong.
It's all half it.
And then this would be the, no, it's calculated right. And this would be your reach act. And then all of that's the same. I mean, you guys, are you starting to see a pattern here?
Yep.
This is pretty much all the same. This is your offset speed. Or, G54 is your offset. Here's your height offset, G83, and then Q2. You guys remember what that is? Height depth. Counterboard. I actually counterboard this one with an end mill. You guys can also use real counterboards if you wish. I'm fine with that. But I just want to go with an end mill.
Yeah, it works.
And then at the very end, it goes G28, G91, G28, G91Y0. I didn't slide the table off to the side, and then G90 and an M30. M30 means what?
And the program send it back to start.
Yep. And then don't forget the percent sign. If you're forgetting the percent sign, it will not work. And my suggestion is you can type it in any Word thing, or any Word type document, but you have to say it a certain way. It's in your book. And it works better if you type it in. There's less problems if you type it in that way.
Because there's less saved options, I'm assuming.
Uh,
Or less auto-correcting.
Yeah, it's just cleaner and the machine likes it better. If you do something the machine doesn't like, it does this. This was saved directly off the machine, so it's not the one I wrote, it's the one I ran. So I had some note out here that it got rid of because it didn't know how to read it. So that's what those question marks mean in parentheses.
Cool.
So everybody get your book and we'll go over speeds and feeds. I'm pretty sure my book's still in my office because I never made it there after my last class. until John gets back and gets done this. But I gave you guys all kinds of time to do the first one. Because you have to run a guided one, and then you have to write and run this one. Cameron?
Yep.
And then do your safety test, and it's all due that day. But if you notice, this one's due at the same time.
Yep.
I gave you a little extra time, but then we gotta play catch up. Because this week's been all funky.
You made my camera issue.
Camera issue, first day of school, and all that stuff.
So I might end up being here tomorrow anyways, I gotta sort out stuff for the one I'm
Like I'm in to run this project.
Yeah, but I'm not here as well.
A good chance I'll be here tomorrow if I'm not in a meeting, because I'm gonna come in and work on this stuff. I'll clean it up for you guys.
I promise I won't try to break anything.
Nobody tries, I hope. John, here's your due date for the first module. You gotta do the safety assignment, you gotta do your guided project, which is the one I wrote, and then you have to write one to do this one. This I'll delete, unless it's something that I care about. If you look up here, you have a video for speeds and feeds, you have a video to set up your bikes, you have a video to indicate, calibrate, all that stuff. So it's in there to help you. Your guys' book's not in here? Well, that's no fun.
Syllabus?
No, it's not. Yeah. Hurry up, John, we're gonna go over speeds and feeds.
On this day, next short, light heat.
I'll put your house book in there. They're in the first, up in that top part, or up above it. I thought all of them had a book in.
Oh, are they still qualifying the sitting in the front row and get 8%?
There is no front row.
There, we are all in front of.
I saved those. Mostly for assignments I just didn't bother to do, but
While John's gone, you guys that have programs, you can put the simulators in the cabinet. And so I'll go get my book and
I was taking these simulators home right now, they shouldn't mind.
They used to have them on immersive, but then they're broken. They didn't work. It's great.
They stopped using immersion, right?
Yeah, they're done.
Thank
They're
God.
done. Yeah.
Well, what worries me is I think it was in 103's modules, it's still all immersive stuff. I think 103 still has all immersive stuff in the modules. It hasn't been updated yet, but there's
That's one X. Not the question mark. I was getting confused at like the question mark, yeah, hold that shift, but dance, you know.
yeah.
Use question mark.
I will say this is so much easier to learn than people are. So I just print it all on screen.
Yeah. I got mine right here.
See, one of the things I'm thinking of with my next way stuff is gonna have a fatter middle so it can support the screws and the posts. And it's gonna actually have a nice thinner step down, sturdy enough that it doesn't get bent. But that way, if you're milling a side of something, it's clearance for the cutter. And if you have to flip it over, now there's no. Well, it's still gonna work with it.
What do you want it to do, like exactly? Make out a list of what exactly you want it to do.
Yeah.
And then go over solving everything on that really checklist. Just like one of my devices and I think.
I mean, the game the program, like the one I have would work. You can just mill one side and you flip it around. It's still.
And then just make sure you get both sides clean.
Yeah.
And
Just
then
clean the second side off the second side of the program. You just change some of the dimensions so it fit.
I mean, I have this, I'm just gonna clean up the sides manually, just like run it across, and then I'm not gonna try to do any special tricks with it, I guess. And then, once it's down to size, I'll throw it in, and then should be fine. I wanna do this on steel too, so I'm gonna have to adjust my speed.
I'll do mine at half alloy. Super alloy for the win!
Yeah, run it in high speed steel. High speed steel's good.
You would not be able to cut acetyl with high-speed steel.
You can try.
It's gonna friction weld.
Would it though?
Probably.
You know that.
I mean, you're drilling at 2/10,000ths of an inch per rotation with acetyl with like tougher carbide bits.
That's no problem, nothing fast enough.
You know, next time I'll just crank it to 2,000 RPM in just 1 inch per revolution. Just
That's
force
it.
it through.
Yeah.
Yeah. That's the size that machine went. It was old POS.
Oh, okay. That nice still picture of I'm gonna be using it a lot.
I'm pretty sure that machine was built probably the mid-80s. So it was older than I was.
We got a machine that we had some like problems coming in the shop from the phone and machine shut off. Won't turn back on.
We had a power fluctuation spike one day, killed every single machine. Like the lights just go. I'm like, what the? I don't know. It was mid boring bar, so the boring bar was still stuck inside the piece. And I'm like, that's gonna be an issue when I home it, because it goes, X and then Z. And I didn't realize, because some machines you can't move anything until you home it. Thankfully on this machine you can jog it before home it severely enough. But it was like, how bad is that? The supervisor's like, no, it happens all the time, just restart the machine like that.
Yeah. I was in the middle of tapping. But it's on an out lathe, so it's kind of like a manual lathe.
Oh,
It's got like a tailstock on it. So I just took the tap on the back.
yep.
Well, they're out like in. Then we got off work for like 2 days till they got it fixed.
Nice.
But we didn't get paid for it.
Yeah, that's the shit part.
It's like, well, you can work Friday and Saturday if you want. I work Friday. I don't work Saturday.
Yeah. It's like, hey, I know you enjoy your weekends, but I need you to come in. Well, due to traffic, it might be a little late. How late will you be? Monday.
Maybe Tuesday. Depends.
Yeah, maybe Tuesday, depending on how much you drink. How much you party. What you got? We had one guy in Fido who was working there 50-some years. He was like on his 57th year working there. It's fucking. He's basically been there since the start of the company. I think Fight was founded in the 40s. Fuck it, they didn't hire me.
They pay very good up front.
Intern, 16-hour training, 18 to 20. Machinist 1, 20 to 23. Night shift, extra $150. But if you roll from a machinist, and as a machinist, program, you only run machines. You have like one program.
Okay. I got interrupted like 6 times on the way, I mentioned that.
Uses.
Machine is great too, it was actually a pretty significant jump.
What page is the speeds and feeds on, guys? I found it. Right this time I asked, my fingers just turned to the right page. So you guys have all your formulas over here on page 172. So on your wheel, when you're calculating your speeds and feeds, the first thing you really got to figure out is your RPM. So that's for surface feet per minute times the short version is forward.
I just do 3.82 because it's easy.
3.82 is way more accurate. When you guys get to use the carbide in 119, you guys have to do that one or it'll mess it all up.
That's what you use anyways.
Divided by the size of the tool equals RPM. So your surface feet per minute is on page 173, right next to it, John.
Yeah.
So your surface feet for carbide, which is your shell mill, because it's got inserts in it, right? Is 600. So if I was doing John, are you with me?
Sure, so it's 180 for us.
I got a great book.
All the way in the back.
It's like the last 3 pages.
There you go.
So, your shell mill's carbide. So that would be 800. If you look at the limit, you look at the carbide, you get 800. Follow it, John? So then you take your 800 times 4 divided by
3.
the size of the cutter, which the size of our shell mill is 3.
Most summer 2, some 3.
Oh, those are 3. Yeah. They make them way bigger than that.
Oh, yeah.
I've seen them like this.
We got a couple. We got like a big boring mill at work.
There's one in Maxi. I think it'd take you a whole shift to change the inserts in. So,
We'll bring our own stuff in there sometimes, do blocks and then.
I was there, they had I think it was a 2.5 inch diameter roughing in mill. That long, they were roughing like almost a single pass, it was shaking most of the building. With how much chatter they were getting. But they had it like on the slowest possible setting they could and it was still chattering like that.
sometimes go as slow as you can make some chatter.
I don't know. They knew what they were doing, but it was shaking the whole building.
It wants a certain chip load, and that's set by the manufacturer. Unless you give it that, it cuts down on the life of your tool, and it will create heat and do all kinds of work.
Yeah, but if you're not buying the tool,
Yeah.
true.
Sure.
Trying to kill as much time till shipments.
I've never been a fan of that. I wonder for the much guys that did that.
Yeah.
So then after you know your RPM, you do RPM times your chip load, which is on the back of the page. So chip load for aluminum, and we said bigger than 1 inch. So that's 7 thousandths. On this side. There you go. See where it says aluminum? Greater than 1 inch, because that's our cutter's greater than 1 inch. On the lathe, it's the other way. It's the size of your saw. So it says 7 thousandths. So you would put RPM times that 7 thousandths times the number of flutes. So our shell mill's got what, 5 or 6?
It's 5.
5. So you would take it times RPM times the 7 thousandths times 5, and that gives you your inches per minute. Follow? So these are pretty self-explanatory. Calculating the end-mill depth per cut. It gives you an equation to that. Calculating tap feed for a mill. This is important. You cannot do this wrong or you will break you. 1 divided by TPI. So say I'm doing quarter 20. It would be 1 divided by 20 times your RPM. And we usually run we teach you all in this class, we run them at 100. Usually, just every one of them, because it makes the math really easy.
So wouldn't that just be the TPI divided by 100 then? If it's
It's 1 divided by TPI,
what is it?
which gives you a great big huge decimal, times 100. So do 1 times 20, Enoch, and then multiply by 100.
1 times 20 or
1 divided by 20 times 100.
times 100. That's 5. So, and if I just did 20 divided by 100, yeah, wait, you have 1. You know, it was 100 divided by 20. Gives you the same thing. So and so for, let's say if it was 3/8/16.
Well, the feet per revolution is 1 divided by TPI. The thing is, if you change that 100 to like a 200, you're probably wrong. It just happens to work out because the numbers we use, I would imagine.
Let's, if I did a 3/8/16, then that would be divided by 16, just 6.25.
Now, say you're going 200 inches a minute, it's going to be wrong.
200, what do you mean 200 inches a minute?
Or
200
RPM, I mean. It'll probably change the answer. I imagine you get 2 different things. It just happens to be because we use 100.
12.5. So 12.5 is what I got when we got that. So we do
What size was that?
It was a 3/16, so
16. So it's be 16. 1 divided by 6. 6.25.
6.5. Yeah, so it'd be the same feed rate if it was going at twice the spindle speed. That
Same feed rate at twice the spindle speed.
yeah, because the spindle speed was 100. I mean,
If the speed rate doubles, your feed rate's got.
Yeah.
I know. But that's it. If I do it the way that's in the book, then it says it's the same feed rate.
So 1 time or divided by your 16 times 200 gives you the same answer. 1 divided by 16.
Okay, one of you do it one way, one of you do it the other. Somebody do 1 divided by 16.
Okay, I got the same exact thing both ways. Yeah, I messed up that method, and it's the exact same thing. If you
I just always looked at the book and used the formulas in the book.
yeah, I just remembered from last semester I would just divide the
So calculate drill point when you guys are doing a hole that's not a through hole. What's that?
Good question.
Don't tell, I said don't tell me somebody's bleeding.
No. Do we have any more water stock somewhere?
There's some back there on the floor or in that cabinet. Look in the cabinet first.
Okay.
Calculate drill point. It's the diameter of the drill times 0.3. If you want to just do the whole thing at once, I usually just do 1.3. That way it puts the tip and the wick together. It's just the way my brain works. But really, it's probably less confusing if you just do the times 0.3. So if we're doing a 1/2 inch hole and you want a blind hole and it's in a 1 inch block and it's going down 1/2 inch and you need full diameter to 1/2 inch, you take 0.5 times 0.3 and then add that to your depth.
It'd be 650 thou.
Make sense? Calculate 45-degree chamfer depth. We already talked about this. Chamfer is equal to the radius of the chamfer major diameter. So it's also the hole divided by 2. So that gives you the radius. I'm sure John's head probably feels like it's going to explode. Is everybody else good?
No.
Makes sense, Cameron? Let's go work on some pros. Somebody go fire up the one with the panic robot. The one that's up there in the corner. Because it's got everything we need to do this. And would one of you grab your toolbox, please?